Thank you. I'm Paul Wilkinson from the British Geological Survey, and I'll be presenting some results from the geoelectrical monitoring systems that we've installed at the UK GEOS Glasgow sites. I'd like to begin by acknowledging my colleagues from the Environmental and Engineering Geophysics team, and also from the wider BGS for their input into this work. The imaging technique that we use here is known as electrical resistivity tomography, or ERT. It allows us to make images of the ground between the boreholes of the three sites. Specifically, these images are of the distribution of the electrical resistivity, which is a physical property representing how much the ground resists having an electric current pass through it. The ERT images that we get are useful because the resistivity is sensitive not only to geological variations, but also to changes in groundwater and, really importantly here, changes in temperature. We've developed a system called Prime that lets us use ERT for remote monitoring. It's shown here in this cabinet, and there's one of these systems on each of the sites. It's connected to electrodes that are mounted on the borehole casings. In this photo here, you can see the electrodes that are strapped to the casing and the gravel pack. There are 72 electrodes in the deep holes and 24 in the shallow holes, all spaced at 75 centimetres. The way it works is that we inject a current into the ground between two of the electrodes, and then we measure voltage differences between other pairs of electrodes. We repeat this in different patterns up and down the boreholes, and these measurements are sensitive to different parts of the ground between the electrodes, shown by these diffuse yellow regions. When the electrodes are close together, then we are getting information from regions that are close to the borehole, and when they're further apart, we're looking out to greater distances. The raw data then gets processed and turned into an image of the resistivity distribution in the vicinity of the boreholes, like this one shown here. Now, I've done this at each of the three sites, and these are the images we get. The reds and orange colours, these are high resistivities, which tend to be associated with sands, gravels, sandstones, and the greens and yellow colours, low regions of lower resistivity, which tend to be more associated with mudstones and clays. And at the Glasgow sites, the mine waste also tends to have quite low resistivity. So those images represent the geological structure, but by making repeated measurements over time, we can also use ERT to monitor changes in the resistivity of the ground, in particular, the heat extraction experiment that was shown in the previous talk, where heat was extracted from water that was pumped out of the Glasgow upper mine working via GGA07 at Site 3. And then the cooler water was re-injected at Site 1 via borehole GGA01. We monitored this process, making sets of measurements every half hour. So this is the baseline image from Site 1. We can quite clearly see the mine workings as this band of lower resistivity due to the mine waste. And this image was taken about an hour before the experiment began. Now, if I start the animation, the pumps switch on, and straight away we see this area of higher resistivity, which is indicative of lower temperatures. These temperatures seem to affect the full extent of the screened interval, and they reach the deeper hole on Site 1 within a day or so. Now, the magnitude of the changes is pretty much what we'd expected them to be, as resistivity typically increases by about 2% per degree of cooling. We can see some other interesting effects. If I just rewind the video slightly, we have this cooling in the vicinity of the injection borehole. This is probably due to conduction through the casing. And we also get some similar changes in the other hole, which may be due to the heavier fracturing and grouting variations that hole was affected by. Now, towards the end of the experiment, as the pumps switch off, we see a gradual return towards equilibrium, although within the last couple of days, water was extracted from GGA01 for sampling, and we see some changes around that borehole which coincide with that. These will be just coming up here in a second, just this region. Now, the nice thing about the ERT monitoring, it allows us to see processes like heat transport in the ground volumetrically away from point sensors. So it provides a lot of complementary information to the other sensor types that are installed at the site. And I think it's going to be very useful for characterizing the geothermal resource here and identifying potential pathways for environmental impacts. So that's everything from me. So thanks very much for listening.